In 1950, the fishing village of Shenzhen in southeast China had just over 3,000 inhabitants. By 2025, this number will exceed 12 million, and Shenzhen is not alone. Urban areas around the globe are growing by 200,000 people per day. And all these people will need affordable housing, as well as social transport and utility infrastructure. This is the starting point for a new report by the World Economic Forum and Boston Consulting Group entitled For Shaping the Future of Construction. Inspiring innovators redefine the industry. It highlights 6 building projects that demonstrate the innovation in construction that the world needs in order to meet this enormous challenge. Welcome, my dear friends, to INBAC. Today, we are going to study this interesting article in the form of case study. So without much ado, let's get started with me, Adrija, your learning buddy. It's the world's most sustainable and connected office. Deloitte's New Amsterdam head office, The Edge, shows how smart building design can provide flexibility and comfort for its occupants while also reducing energy demands. Producing more energy than it consumes, The Edge is widely regarded as the most sustainable office building in the world. The multi-story north-facing glass atrium admits lots of daylight while concrete walls on the south absorb heat from sunlight, and solar panels convert that sunlight into energy. A single network controls every technical system in the building, including a network of tens of thousands of sensors placed around the building. The lift, the lighting and cooling systems, coffee machines and towel dispensers, even the robot security guard which cruises around the building at night can all be controlled and adjusted centrally. Combined with the hot desk approach to working, the technological flexibility of the building means that its 1,100 workspaces can serve more than 2,500 staff. Amazing, isn't it? Next is a very interesting project. New Karolinska Solna University Hospital in Stockholm, an example of how to make healthcare infrastructure smarter. When completed later in 2017, the New Karolinska Solna University Hospital in Stockholm had over 12,000 rooms, 35 operating theaters, and 17 MRI scanning units. It is considered to be the world's largest public-private partnership project. The NCASE contract required the use of Building Information Modeling, BIM, which provided a single system for designers, contractors, and facility managers to collaborate on. All information relating to the hospital's design, construction, and inventory is stored digitally. Ultimately, BIM data will enable the hospital facilities to be managed comprehensively and serve as a map for 29 automated guided vehicles which will deliver medical supplies, laundry, and other items around the site. NCASE will also be climate neutral, thanks to its energy-efficient insulation, a geothermal energy plant, and the use of food waste for biogas. Now, let's learn about how to build social amenities faster and more affordably. Creating low-cost housing and social infrastructure is a challenge across the globe. A project to create much-needed courthouses in Tanzania may have shown a way ahead. The Molari construction system replaces the cumbersome bricklaying process with an approach akin to injection molding. Workers erect the building's frame with reusable plastic panels, leaving wall cavities which, once the windows, doors, wiring, and pipework have been put in, are filled with fast-setting aerated mortar. The building process can be monitored by just one qualified supervisor who manages local workmen with no prior construction experience or skills. The first project, Kibaha District Courthouse, was built for $250 per square meter, just imagine, which is half the cost of conventional methods. It took 6 months to complete when it might typically have taken up to 3 years using traditional methods. On the back of this success, the Tanzanian government has committed to building another 11 district courthouses using the same method. Now comes the vertical city. Any guesses? Okay. So by 2050, 2/3 of the global population will live in cities. In many urban centers, there will be shortage of space on the ground, and expanding outwards won't be an option. Instead, cities will need to build upwards to accommodate their workforces and residents. The idea behind the design of Burj Khalifa in Dubai, now a popular tourist attraction, was to create a mixed use of modern skyscraper with hotel accommodation, residential apartments, and commercial premises. Not so much a building as a vertical city, isn't it? Moving ahead, this report credits the realization of this vision to securing the backing of the authorities, including the ruler of Dubai. Close collaboration among all contributors, using prefabrication to speed construction, and pioneering the use of innovative technologies such as self-climbing cranes. The Burj Khalifa is now the third most popular selfie attraction in the world, after the Eiffel Tower in Paris and Disney World in Florida. Next is the 3D printed bridge. It is hoped that a printed steel pedestrian bridge in Amsterdam will show that additive manufacturing techniques or 3D printing can work outside the lab in the real world. The bridge aims to showcase the technology's viability and potential to the construction industry, while also contributing to developing a strong supply chain and customer interest in 3D printing of projects of this scale. In addition to speed and time of construction, 3D printing technology offers environmental benefits too. Being managed digitally from the design to the production phase, it generates no waste and there's little need for rework. Material savings through optimized shapes also mean that 3D printing is a highly eco-friendly technology. Next is printed house. In China, Vincent had pioneered large-scale 3D printing. In 2014, it succeeded in printing its first house and then created a printed housing estate also. Since then, it has also delivered the first 3D printed office building in Dubai. Compared with traditional on-site construction, the Vincent process saved about 80% on construction costs and 60% on both labor and waste. Challenges for the engineering and building automation sector compared with many other industries. The construction industry has traditionally witnessed slow technological progress and has remained rather set in its ways. It therefore faces a steep learning curve if it is to meet the requirements of creating even more human living space fast and in a cost-effective and sustainable way, the report suggests. The projects that I have mentioned right now have in common a high level of automation, standardization, collaboration, cross-sectoral knowledge transfer, and openness to experimentation. Adopting some, if not all of these approaches, could be the way forward for the sector. Now, there are many figures and statistics in the entire content, which is actually beyond the action scope of INBAC. And still, INBAC sees a need of talking about it because the whole point is we know all this when we measure and we see it in a better light with global benchmarks. INBAC promotes connected buildings, with secure and authentic data flow. Such measurement and benchmarking of data is key to the future benefits. Hope you liked our content today. Stay tuned for more such videos. Bye-bye.